dx. And then these guys, they're just plus or minus, so I can do them separately. 3x squared plus 3y squared dy dx. Okay, I'm going to have to FOIL or distribute this guy in order to get the dy dx's all together. Sorry about that. Okay, so now I can get these dy dx's all on one side. And actually, look, I see I could factor out a 3 on both sides and divide, so I can get rid of those 3's. So I have my x plus y squared minus my y squared dy dx equals that x squared minus the x plus y squared. So dy dx equals x squared minus x plus y quantity squared over x plus y quantity squared minus y squared. And if you want to FOIL these guys, you can see some x squares might cancel, and that's cool if you do. Same thing down here, some y squares. If you wanted to, you could. You would be left with this. But you don't have to. You could evaluate it right here, and we're going to evaluate it at -1, 1. Okay? So everywhere I see an x, I'm going to plug in -1. Everywhere I see a y, I'm going to plug in 1. So let's see. That's going to become 1 minus 0 over 0 minus 1, which is -1. So see how that really wouldn't have helped you in this case. Okay, now taking the second derivative. This is saying find the second derivative. And again, that's going to give you more with concavity, points of inflection. So your steps are to go ahead and find that dy dx just like you did. Then you're going to take the derivative of that dy dx. So up here, I would take the derivative. And again, you're going to probably have dx dy in there. So then you're going to have to go back and sub it in. So you can get it all in terms of just x and y. Okay, so let's look at this first one. If I solve for y, it'd be plus or minus a square root. I don't want to deal with that. So we're going to go ahead and do implicit differentiation. So we're going to take the derivative. So that's 2y dy dx equals 4. So solve for your dy dx. Now we're going to take the derivative of that. So the derivative of dy dx is dy squared over dx squared equals, now differentiate this part.
Excuse me, teacher, please excuse all new students to the new student breakfast in the cafeteria at this time.
And I took the derivative of y, so I write dy dx. But I don't want to leave that, so don't leave. We have to go replace from what we just found up above. So there's our second derivative. All right, I want you guys to try this one, and then we'll see how you do. So then unpause and try it. Oops. Okay. First, second. Now, to take the second derivative, I have to do my quotient rule. Low d high minus high d low all over low low. So everywhere I see a dy dx, I have to go put that back in. So I just kind of wrote out my fractions a little bit easier to see. So basically, if I wanted to get rid of these denominators, I'd have to multiply by 2y minus x over 2y minus x. Sorry about that. And I'm going to go ahead and just make it look a little bit prettier. Okay, so that is my second derivative. Woohoo! But I want in the directions to evaluate it when x is 6. So when x is 6, oh no, what is y? So I'm going to go have to find what that is. So y squared would equal 6y minus 9. So I plugged it into that original equation here. So I can go solve for y. So y squared minus 6y plus 9 equals 0. That would be y minus 3 times y minus 3. So y would be 3. So now I'm going to evaluate it at 6, 3. That's the answer I got. Woo! What a fun problem. Alright, I'll talk to y'all later.